To solve the problem, we are going to calculate first the consumer surplus for the initial case, theta 0, and then we're going to do it for the final case, theta 1. Now, to do it for the case of theta 0, the first thing that we need to do is identify what the consumer behavior is. So, what is x star of theta 0? Since this is free trade, it's easy to see that it's just the demand at price P, which we are given is just the max of 0,100 minus P. Now we can plot that here just to get some graphical intuition. We have x here, P here. The demand is just a line like this that crosses at 100 and at 100. Now, what is going to be the consumer surplus at a price of 50, which is what we are asked for? Well, we know that at a price of 50, by the formula, the consumer demands 50, and we know that the consumer surplus is going to be given by that area. So we know that the consumer surplus at a price of 50 is going to be equal, for this case, theta 0, to the area of that triangle, which is simply 50 times 50, 1/2, because it's a triangle. So 1/2 50 squared, which is just equal to $1250. Now let's look at the case of theta 1 when the subsidy is introduced. This is also very easy to compute, but you need to think your way correctly through the problem. So what is the demand in this case? Well, at any price P, the consumer only pays half the price. So how much is he going to want to buy? He's going to want to buy the same thing that he would have demanded if the prices would have been only half. So in other words, his demand is max of 0 or 100 minus P divided by 2. That is the impact of the subsidy. Notice that this implies that at a price x star, theta 1 at a price equals 50 is 75. So the consumer ends up buying more units after the subsidy is introduced. Now, let's compute the consumer surplus for this case. The key thing to remember is that the marginal benefit curve that determines the consumer surplus has not changed and is given by the demand curve in the absence of any additional thing to free trade, like a subsidy or a tax. So we know that this curve, which has equation 100 minus P, is also the marginal benefit when we look at it from this case. So we know that x star of P equals 100 minus P also implies that the marginal benefit function, P prima of x, is equal to 100 minus x. So we know that this curve is 100 minus x. Now we also know that the consumer demands 75, and at a price of 50, he's going to buy 75 units, but he's not going to pay a price of 50, he's only going to pay half the price because of the subsidy. So we know that he's going to end up buying at an effective price, let's call that price effective, of $25. So what results? What is the bottom line? He gets to consume all of these units, only pays half the price. That means that the consumer surplus ends up being all of this area. The area, basically all of this trapezoid, is the benefit that he consumes minus the cost that he pays. So that is the consumer surplus at theta 1. What is that consumer surplus? When the price is 50, let me put here theta 0 and theta 1 is equal to the area of the triangle, but the area of the triangle is 75 times 75 divided by 2. That is equal to 2,812.5. So if you do the subtraction, you get that the change in consumer surplus from theta 0 to theta 1 is equal to $1,562.5.